Hi guys, quite a few of you have asked for solutions to the 2018 Northern Hemisphere Specialist Exam 1. So I thought I'd download it and give it a crack. So here it is. So this is the official exam from this year, 2018. Usually Northern Hemisphere seems to be pretty hard, especially with Spech. So it's 8:20 at night, so hopefully I can fire my brain up and get through the question. Okay, so what does it tell us? Answer all questions in the space. Exact answer is required to the question. If there are more than one mark is available, you must show work. Must otherwise indicate the diagrams in this book are not drawn to scale. Take the acceleration due to gravity as g meters per second squared, where g equals 9.8. Perfect. Okay, a light and extensible string hangs over a frictionless pulley connecting masses 3 kilograms and 7 kilograms as shown. Draw all the forces acting on it. So we would have a 3g force here. We would have tension going up. We would also have tension going up here, and we would have a 7g force here. That's it. Okay, calculate the tension in the string. So it's going to be accelerating downwards because 7 kilos is lighter than 3 kilos. There's no other forces. So we would have 7g minus t. So that's our resultant force. That's equal to mass times acceleration. So 7 times a. Equation 1. On the other side, I would be going upwards. So I would have t minus 3g equals 3a. That's equation 2. Okay, if we do 1 plus 2, our t's are going to cancel. So I get 7g minus 3g is equal to 10a. So 4g equals 10a. So a equals 4g on 10, which is 2g on 5 meters per second squared. Calculate the tension in the string. So from this, we can see that tension is 3g plus 3 times 2g on 5. It's not very neat there. Remember that that's a 5. Okay. So we put that on 15. We're going to get t equals 15 g on 15. What am I saying? 15g on 5 plus 6g on 5, 21g on 5 newtons, because it's a tension. I like to put a nice square around my answer, or a rectangle. Okay. A is 3i minus 2j plus mk. B is 2i minus j plus 3k. Where m is an element of real. Find the values such the magnitude of the vector resolute of a vector A parallel to B is root 14. The magnitude. Okay. So first we want to find B hat, which we know is 4, 1, 9. It's going to be root 14. So 1 on root 14, which is root 14 on 14, times 2, negative 1, 3. Now if we do A dot B hat, that will give us root 14 on 14. Root 14 on 14, 3, negative 2, m, dotted with 2, negative 1, 3. So we're going to get root 14 on 14. Okay, I'm going to get 6 plus 2 plus 3m. So root 14 on 14, 8 plus 3m. Okay, now the magnitude of the vector resolute of A parallel to B. So if I find A dot B hat, and then the magnitude of that. So we know that is A dot B hat. If I multiply it by B hat, the magnitude of that is just 1 because it's a unit vector. So it's just this. So I've got root 14 on 14, 8 plus 3m, times a unit vector, which is just 1. That equals root 14. Now, if we've got magnitude sides around the outside, we've got to, when we bring them, like when we basically undo the magnitude, we can just put plus or minus on the other side. So I get root 14 on 14, 8 plus 3m is plus or minus root 14. Now, if I divide that root 14 to the other side, I'm going to get 8 plus 3m is equal to, the root 14s will cancel, I just get 1, and when I times it by 14, I get plus or minus 14. So we get 3m is equal to minus 14 minus 8, and 3m is equal to plus 14 minus 8. So m is negative 22 on 3, and m is 14 minus 8 is 6 on 3 is 2. When it said values, I thought there must have been multiple values. So m is negative 22 on 3. I think a lot of people would forget the fact that this, when you bring it, like when you get rid of the modular signs, it's plus or minus on the other side. They might just get one solution. Okay. Given that arc cos is that, arc tan is that, sine t. I've got to remember what the bloody rule is for two angles. Sine of x plus y. Oh no, formula sheet. Where's the formula sheet? Sine x plus y. Sine x cos y plus cos x sine y. That's what I was going to say it was, but better to be safe than sorry. So sine x cos y plus cos x sine y. So in this case here, we've got two triangles. I want to say, let's say that's theta. I know cos of theta is 12 on 13, so 12 on 13. 169 minus 12, that's going to be 5. And the other one is a 3, 4, 5, and that's tan. Tan is 3 on 4. We'll call that alpha, and say that that's 5. Okay, so I have sine of t. So this is my x and this is my y. So I have sine of cos inverse 12 on 13 times cos of y arctan, tan inverse of 3 on 4 plus cos of cos inverse 12 on 13 times sine of tan inverse of 3 on 4. Now, cos inverse of 12 on 13, that's the same as sine inverse of 5 on 13. So, sine inverse 5 on 13, cos of tan inverse 3 on 4, that's the same as cos of cos inverse of 4 on 5, plus cos of cos inverse 12 on 13, we know that that's just 12 on 13, times sine tan inverse 3 on 4, sine inverse is going to be 3 on 5. 5 on 13 times 4 on 5 plus 12 on 13 times 3 on 5 20 on 65 plus 36 on 65. What's 20 plus 36? 56 on 65. Sine t equals 56 on 65. Hopefully that's right. Okay, throughout this question we use an integer multiple of the standard deviation in calculation, so they mean like mu plus or minus 2 sigma is 95%, 1 sigma is 68, 3 sigma is 99.7. Now the standard deviation of the scores on a particular test, all scores, so that means a population, so that's S is 21. When the results for a random variable or a random sample of n students and 95% confidence interval for the mean score for all students was calculated to be that. So that's our confidence interval. Calculate the mean score. Okay, the mean score is the halfway mark. So mu is 44.7 plus 51.7 on 2. What's that? 95, 96.4. Half that, 48.2. So that's our mean. Now, our error, how far it is off the mean. 51.7 minus 48.2 is 3.5. So we've got mu. Calculate the size of the sample. So we know our error, which is 3.5, or 7 on 2, is equal to z, which in this case is 2, because it's 2 standard deviations, times s, our standard deviation, 21, on root n. I think that's on your formula sheet. Okay, so we got 7 on 2 equals 42 on root n. So we're going to get root n is equal to 42 divided by 6 times by 2 is 12. So n equals 144. So therefore, n equals 144. Oops. That's really annoying. How do I undo my undo? Bloody hell. Okay, you know what I just did. So what did we get? The mean was 48.2. Hopefully it hasn't deleted everyone else. Okay. The mean is 48.2. Our error, we said, was 7 on 2. That equals 2 standard deviations times my standard deviation. My z value is 2 on root n. Okay, so we got root n was equal to 12, so n was equal to 144. So therefore, mu equals 48.2, and n is 144. Okay, determine the size of another random sample for which the endpoints for the 95% confidence interval for the population mean of a particular test would be 1 either side. So the 95% confidence interval, so it's going to be a larger sample because it's not as big. The error is not as big. Because I get 1 on 2 again, because it's a 95% interval. So we know that our z value is 2. Times our standard deviation is still root 21 on n. Okay. I've got 42 on top, so I get root n is equal to 42. So n is equal to 42 squared. 42 squared, what's that, 1600, 1764, is it? Think. 1762, 1764. So, didn't do my nice. 1764. 42 squared, 1764. Okay, next up, let's see what we've got. 2 root 3 minus 1, 1. Okay, the top isn't a derivative of the bottom. We can't use a linear substitution. The only thing I'm thinking is, because we've got up here, our numbers look like they're going to work with a circular function. So let's say 1 on, let's just see what happens. X squared plus 2x, if we complete the square, plus 1, minus 1, plus 5, x plus 1 squared, plus 4. Okay, we can do that. So we can say that's equal to, from 1 to 2 root 3 minus 1, 1 on 4 plus x plus 1 squared. Now that looks a lot like a tan, but we're going to have to use a substitution for x plus 1. So let's let u equal x plus 1. Du dx is therefore 1. When x equals 2 root 3 minus 1, what's that going to be? Plus 1, so I'm going to get u equals 2 root 3. I just subbed it into there. When x equals 1, u equals 1 plus 1, which is 2. Okay, so let's have a look. We've got our u values now. So we go from 2 to 2 root 3. I'm going to say 4 plus u squared, and then du, because du dx is replacing dx. Now if it's tan, that's a squared, so that's got to be 2 on top, so I've got to put a half out the front. That looks good. So we know that this is equal to a half. Tan inverse x on a. Now a has to be 2, because that's 2 squared and that's just 2, so a on 2 between 2 root 3 and 2. So I've got a half tan inverse of root 3 minus tan inverse of 2 on 2, which is 1. Okay, 1, 2, root 3, pi on 3, pi on 6. That's equal to 1/2. What's tan inverse of root 3? It's pi on 3. Minus tan inverse of 1, which is pi on 4. That's from our other special triangle, 1, 1, root 2. Okay, pi on 3 minus pi on 4. So 4 pi on 12 minus 3 pi on 12 is just pi on 12. A half times pi on 12, which equals pi on 24. Final answer, lock it in. Okay, what's up next? A tip for that question. Okay, number 6. Given that x is x, y is that is a solution to the dE, a d squared y dx squared plus b dy dx plus y. Find the values of a and b where a and b are real constants. Okay, so we've got what y is. Dy dx is product rule. Derivative of x minus 1 is 1 times e to the 2x. Derivative of e to the 2x is 2 x minus 1 e to the 2x. So I get e to the 2x plus 2x e to the 2x minus 2e to the 2x. Okay, so I'm going to get minus e to the 2x. So I can take out e to the 2x, and I'm going to get 2x minus 1. Because that and that give me negative e to the 2x. So yeah, that makes sense. Okay, d squared y dx squared. Okay, let's derive the e to the 2x. So 2e to the 2x times 2x minus 1 plus derive that, we get 2. So I get 2e to the 2x, which is 4x e to the 2x minus 2e to the 2x plus 2e to the 2x, that's nice, they cancel. So I get 4x e to the 2x. Okay, a dy dx. So a, 4ax e to the 2x. That's ad squared y dx squared. Let's make it better. Let's take out e to the 2x. Put the e to the 2x out the front. E to the 2x, 4ax plus b. Do the same thing. E to the 2x, 2bx minus b equals e to the 2x, x minus 1. Okay, bring it all to one side, so we get e to the 2x, 4ax plus 2bx minus b, that's going to be minus x plus 1. Okay, e to the 2x equals 0. E to the 2x is greater than 0 for all x, hence no solution. Okay, so now we can equate coefficients. So I've got 4a plus 2b minus 1 is equal to 0. And I've got minus b plus 1 is equal to 0. Therefore, oops, let's just do that. Therefore, b is equal to 1. So 4a plus 2 minus 1 is equal to 0. So a equals negative 1/4. So therefore, final solution is b equals 1. A equals, is that right? Negative 1/4, yep. Of course, we could check that if we had time, but at the moment we don't, because we're trying to smash through this exam. Okay, nice and easy one. Find the derivative of that. So you could use a chain rule, like by hand, but I'm not going to do that. A half times the derivative of the bracket, 2x, times the bracket 1 minus x squared to the negative a half. Those twos are going to cancel. So we're going to end up with negative x on top, and then square root 1 minus x squared on the bottom. It's a nice easy 2 marks. Hence, 1 minus x squared to the half, that is 1 minus x squared to the half. So I think that's what they're trying to get us to see. Okay, so we've got dy dx. Hence, find the length of the curve specified by y equals root 1 minus x squared from x equals a half to root 3 on 2. Give your answer in that form. Okay, the length of the curve is from a to b, 1/2 to root 3 on 2. I reckon this is going to have something to do with sine, cos, or tan inverse, because look at those terminals. Okay, we know it's a square root of 1 plus dy dx squared, so negative x on root 1 minus x squared squared dx. Okay, let's see what that cleans up to be. So I've got 1 plus x squared on 1 minus x squared, which is equal to 1 minus x squared plus x squared on 1 minus x squared. So they cancel. So we can say this is equal to 1/2 root 3 on 2 square root. What did I get? 1 on 1 minus x squared dx. Now that doesn't look that great until you square root the 1 and it's just a 1. So go 1/2 root 3 on 2, 1 on 1 minus x squared dx. Of course, we know that that is inverse sine when we integrate it. So sine inverse of x on 1, so it's just sine inverse of x between root 3 on 2 and 1/2. Of quick triangle, 1, 2, root 3, pi on 3, pi on 6. Always do this so I don't stuff it up. Okay, so sine inverse of root 3 on 2 is pi on 3. Sine inverse of pi of a half is pi on 6. If we subtract, pi on 3 minus pi on 6 is pi on 6. So that's our length. Enter it in the form k pi. That looks like k pi to me. K is 1 on 6. Okay. Come on, brain. How long have we got? We've got a few more to go. Okay. Let's have a look. A circle with a complex plane in the complex plane is given by that relation. So it's been moved 1 to the right, up 1, and it's got a radius of 2. So there would be our center, 2 to the right, 2 to the left, 2 up, 2 down. It's going to look like that. I didn't even read that it was going to ask me to graph it, but I'm assuming that they want me to because there's a graph there. Sketch the circle on the Eigen diagram below. Oh, what if I could draw it on this? So it's like really nice. Because this usually... so the stupid thing. Where did I want to go to? Up there. Bring up. How's that for a circle? Okay, looks pretty good to me. Hand drawn, of course. Okay, did it ask us to do anything else? Sketch the circle. Okay, so the center's there, it goes down to the, yeah, perfect. Okay, write the equation of the circle in the form x minus a squared y minus b squared equals c. Okay, so it's been moved 1 to the right, so x minus 1 squared plus 1 up, xy minus 1 squared. It's got a radius of 2, so it's going to equal 4. Okay, and show that the gradient of the tangent of the circle can be expressed by that. So, d dx of x minus 1 squared plus y minus 1 squared equals 4. When we derive the first one, we get 2 x minus 1. When we derive the second one, we're going to get 2y minus 1 dy dx. Of course, that's a chain rule. That equals 0. So we get 2y minus 1 dy dx is equal to 2 1 minus x, because when we bring it over the other side, it's going to become negative, so I flip them around. Dy dx is equal to 2 1 minus x on 2 y minus 1. Dy dx is equal to 1 minus x on y minus 1, which is what they want us to show, so we must have done something right. Okay. Find the gradient of the tangent of the circle where x equals 2. Now we've got what x is, but we need to find out what y is. So, x equals 2. That gives me, what's that going to be? 2 minus 1, 1. So I get y minus 1 squared is equal to 3. Therefore, y is equal to 1 plus or minus root 3. Y in first quadrant. Therefore, y equals 1 plus, don't know why I'm doing all this working, because it's worth 1 mark. 1 plus root 3. Okay, so dy dx, given x equals 2, y equals 1 plus root 3, 1 minus 2, negative 1. root 3, 1 plus root 3 minus 1 is root 3. So that's our answer. Negative 1 on root 3, that makes sense because it's going to have a negative gradient. Find the equations of all rays that are perpendicular to the circle in the form argz equals a. Okay, argz equals a, that's going to be from the origin, it's just going to produce an angle, which is a ray. So if it's going to be perpendicular, it's got to be at right angles, so it's going to have to be that and that, because we know that's a tangent, so if they're perpendicular. So we know that angle there is pi and 4, and we know that angle around there is negative 3 pi and 4. So I'm going to say arc of z equals pi and 4, and arc of z equals negative 3 pi and 4. Remember, you have to give it between negative pi and pi. So they are our two answers. Arc of z equals pi and 4. Arc of z equals negative 3 pi and 4. I've got to be getting close to the end now. Question 9. How many questions is there? Oh, that's it. Okay, given that cot 2 theta equals a, what's cot 2 theta? 1 on tan 2 theta. What's tan 2 theta? What's tan 2 theta? What's tan 2 theta? Okay, because it's 1 on tan 2 theta, we've got to flip that upside down. So 1 minus tan squared theta on 2 tan theta. 1 minus tan squared theta on 2 tan theta is equal to a. Therefore, 1 minus tan squared theta is equal to 2a tan theta. Cot 2 theta, that's 1 on tan 2 theta, which is 1 minus tan squared theta, just in case they say we don't do enough working, tan theta. Okay, so 1 minus tan squared theta to a tan theta, so that's equal to tan squared theta plus 2a tan theta minus 1 equals 0. Given that cot equals that, show that. So we've done that. Show that tan theta is that. So let's complete the square. We've got tan theta plus a half of 2a, which is plus a squared. Now I would have added on a squared, so I've got to subtract a squared and subtract 1, which is 0. Tan theta plus a squared is equal to a squared plus 1. Square root that and subtract a, so tan theta is equal to negative a plus or minus the square root of a squared plus 1. That's the same, that looks good. Okay, hence show that tan pi and 12 is equal to 2 minus root 3, given that cot 2 theta is equal to 3. Theta is between 0 and pi. Cot 2 theta is equal to a. So in this case, if cot 2 theta is equal to root 3 and cot 2 theta is equal to a must equal root 3. That makes sense, doesn't it? And we know, therefore, tan, because that angle and that angle are the same, tan of pi on 12 is going to equal negative root 3 plus or minus the square root 3 squared, which is 3 plus 1, which is negative root 3 plus or minus 2 Tan of pi on 12 is greater than, it's less than pi on 2. What am I trying to say? So, tan of pi on 12 is positive in the first quadrant. Therefore, tan of pi on 12 equals 2 minus root 3. That's what I wanted us to show. I haven't done my nice. The nice squares around everything. Although these just show that question, so I'm sort of doing. They've all been show that. Hence, show that, given. Okay. Find the gradient of the tangent to the curve, y equals tan. Find the gradient. I feel like they're making us do a lot of work. Find the gradient to the curve at theta equals pi on 12. Okay, so what's the gradient? dy d theta is sec squared theta. So we want to find sec squared of pi on 12. We know there's pi on 12. We know that tan of pi on 12 is 2 minus root 3 on 1. Okay, what's 2 minus root 3 squared plus 1 squared, and then square rooted? That's going to be square root 4 plus 3 is 7, minus 2 root 3 plus 1, so it's going to be the square root of 8 minus 2 root 3. That's what cos, what did I just do? That's a square root of 8 minus 2 root 3. dy dx given dy d theta given theta equals pi on 12 is equal to 1 on cos of pi on 12 squared. Okay, cos of pi on 12 is 1 on, so that's going to be 1 on root 8 minus 2 root 3 squared, so it'll just be 8 minus 2 root 3, because the 1 on will cancel, and then when you square 8 minus 2 root 3, you just get 8 minus 2 root 3, so dy d theta, when theta equals pi on 12, is that. It's nice that it worked out, because I'm like, this is a square root, and I've got to square it under a square root, but when you square it, it gets rid of it, so hopefully I didn't stuff that up, it's right. Okay, last question. I don't know how long this has taken, I don't know if it's been an hour yet. Pretty confident we've done most things okay. A solid of revolution is formed by rotating the region of the graph y equals tan theta, horizontal axis and the lines x equals, theta equals pi on 12, theta equals pi on 3, about the x-axis, horizontal axis, find the volume of solid revolution. Okay, so it's a tan graph, so it's going to look up like that. Pi on 12, this bloody pi on 12, had enough of it. So it's this, rotated about the axis. Okay, so our volume is pi, a to b, pi on 12, pi on 3, y squared, so tan squared theta d theta. We can't integrate tan squared theta, but is it sec squared minus 1? Tan squared theta is sec squared theta minus 1. And we know we can integrate sec squared theta. Okay, so pi pi on 12, pi on 3, sec squared theta minus 1 d theta. Okay, pi sec squared theta, we know that's tan theta, minus, integrate 1, we get theta, pi on 12, pi on 3. Okay, so I've got pi, what's tan of pi on 3? My brain is absolutely mush right now, so tan of pi on 3 is root 3, minus pi on 3, minus tan of pi on 12. Did we work that out before? That's 2 minus root 3. Tan of pi on 12 is 2 minus root 3. Minus pi on 12. That was nice. Okay, so I've got pi root 3 plus root 3. It's 2 root 3. Minus 2. Okay, I've got negative pi on 3 plus pi on 12. Now if we make that a 12, that's going to be a 4. Okay, so I'm going to say pi, let's use a normal bracket, 2 root 3 minus 2, what do we say that was? Minus 4 pi on 12 minus pi on 12, which is minus 3 pi on 12, which is minus pi on 4. Does that look right? Is it even positive? Man, it's not going to be that big an area, is it? Because we know tan's pretty flat. What's 2 root 3? 2 times 1.7 minus 2 minus, what's pi on 4? 3 divided by 4, let's say it's 0.75. So I've got 3.4 minus 2.75, which would be about 0.25, 0.65 times pi. It's definitely positive, so that could possibly be our answer. We've got an answer though. Got an answer. 2 minus root 3, that's right, that's right. A lot of the times, not 100% sure about this, I don't actually find the equations of all rays that are perpendicular to the circle in the form arg of z. Because it's arg of z and it's a ray, it's got to start from the origin. The only ones that are going to be perpendicular are, like I said, anything that lies on that line. So we've got that one, and we've got that one. Hopefully I'm right. If not, goodbye 2 marks. And my possible 50. Pi on 6. What was this? A length, and it said k pi, so that's a nice one. That's a gimme for 2 marks. I don't know, have I stuffed it up? That one's reasonable as well. Pi on 24. 764. 42 times 42. 4, 8, 0, 8, 1, 6, 4, 6, 7, 1. Yep, my brain mathematics was right. 28.2. Yeah, that seems right. Didn't put a square around this one. They would have got confused. That looks pretty good though. I think this made me think that we might have 2 answers, and I nearly forgot that the magnitude would have magnitude around that. Remembering that unit vector is just 1, the magnitude made it a little bit easier. Don't think I've stuffed anything up. 21G on 5N, that all looks good. Alright, hopefully we'll say A+.